All right, so here's our next example. We want to prove or to verify tangent of x minus cotangent of x divided by sine times cosine, sine of x times cosine of x, is equal to secant squared of x minus cosecant squared of x. One thing I didn't mention earlier, but it's in the list, split the numerator. This is a really important tool that gets used in many different places in many different branches of mathematics. Not only this, but in many other places. So I want to talk about split the numerator. You know this, you just might not know that you know it. Split the numerator works like this. What is 3/7 plus 2/7? Well, we know, yes, that's 5/7. But where does the 5 come from? It comes from 3 plus 2/7. Is that right? So if I have 4/11 plus 5/11, how many 11ths is that? That's 4 plus 5/11. Split the numerator is this, but you're working backwards. You play Jeopardy. If I give you the answer, if I give you 4 plus 6/13, what problem did that come from? Well, that becomes from 4/13 plus 6/13, and we have split the numerator. Split the numerator. So starting with sum, and it also works with subtraction, because don't we also know that 3/7 minus 2/7 is 3 minus 2? So it doesn't matter whether this is add or subtract. But if this is addition, 4 plus 6/13, you may write that as 4/13 plus 6/13. It's going to come into play here. See, we have adding or subtracting over a single value, a monomial. And so we are going to be able to split this numerator. Split the numerator happens over and over and over again. It's very important that you don't learn the wrong thing. You may not split denominator. If you try to split denominator, it's wrong. Because I know for sure that's equal to 1. I know for sure this is equal to 1/4. And I know those aren't equal. So, you may split the numerator, you may not split the denominator. All right? So, now the next piece is this. We're going to see if we can prove this. Start with the more complicated side. Well, I'm saying the left-hand side is probably a bit more complicated. All right? So I'm going to start with the left-hand side. Write it down. Oh, another piece. This has no meaning. This is, in the technical word we used in graduate school, this is crap. This is, if you do not have an argument, what you have is garbage. Tan is a color. Cot is something you sleep on. Sin is something naughty, and cos isn't even a word. So, if you do not have the argument, this is wrong, 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 wrong. This is wrong. You must have the argument. You can say tangent, cotangent, sine, and cosine all you want, but when you write it, you must write this as tangent of x, or theta, or t, or there must be an argument. Minus cotangent of x over sine of x, cosine of x. And what I'm going to do is split the numerator. A person might say, well, wait a minute, can't you change all functions to sine and cosine? Yes, you could. That would be a valid thing to do. Very often there's more than one path across the stream. It's like there's a stream with all these stepping stones. There are several different ways you can get across the stream. I'm just going to take the one I happen to see and go with it. That's what you should do. The best path is the one that you see, so long as it's correct. So I'm going to split the numerator. So tangent over this minus cotangent over this. All right? Minus cotangent of x, sine of x, cosine of x. I'm going to cheat over here a little bit. Now it might be a good idea to change this to sine and cosine. We could have done it before, we could do it now. The sequence isn't particularly important. You end up doing essentially the same thing either way. Change everything to sine and cosine. Tangent is sine of x over cosine of x, all great big honking over sine x cosine of x. Minus cotangent cosine of x over sine of x, all great big honking over sine of x cosine of x. So everything is now in terms of sine and cosines. What can we do with this? Do the algebra. Do the algebra. What we have here are two complex fractions. And you know what to do with complex fractions. This divide by that means it's top, multiply by reciprocal of denominator. So I'm going to multiply by the reciprocal of this denominator, which is 1 over sine of x cosine of x. And then same song, second stanza, except I'm going to run out of space. I better be careful here. Cosine of x over sine of x times reciprocal is 1 over sine of x cosine of x. Do algebra. We may, everything here is multiply in this term, so we may multiply, cancel this sign with that sign, and we're left with 1 over, what is cosine times cosine? How can we write cosine times cosine? Cosine squared. Minus, same song, second stanza. Cosine cancels with cosine. We're left with 1 over, what's sine squared times sine? What is sine times sine? That's 1 over sine squared. Yeah? And we're almost home. Good thing, because I'm almost out of board here. We're almost home here. Keep an eye on the target. What do we want? We want secant squared. But watch for identities. Secant squared. We have 1 over cosine squared. Is it clear 1 over cosine squared is secant squared? And similarly, 1 over sine squared is cosecant squared. And so we have verified. We start with the left-hand side, work until you obtain the right-hand side using valid procedures, acceptable procedures at each step of the way.